Throughout this energy series, we've studied many ways that energy can be stored, transferred, and transformed. In this lesson, we'll step back and look at the major forms of energy encountered in physics and everyday life. All of these forms may appear very different. They all obey one of the most important laws in science, the law of conservation of energy. Energy can change from one form into another, but is never created or destroyed. Mechanical energy is the energy associated with an object's motion and position. It's simply the sum of kinetic energy and potential energy. Throughout this series, we've used examples such as roller coasters, pendulums, and falling objects to see how energy moves back and forth between these two forms. When friction is neglected, the total mechanical energy remains constant. Gravitational potential energy is stored because an object position is in a gravitational field. Near Earth's surface, we calculate the potential energy using the equation mgh. The higher an object is raised, the more gravitational potential it stores. As an object falls, this stored energy is converted into kinetic energy. Elastic potential energy is stored whenever an elastic object is stretched or compressed. Springs, rubber bands, and bows all store energy in this way. The amount of energy depends on both the spring constant and the amount of stretch or compression. When released, this energy is usually converted into kinetic energy. Thermal motion is associated with the random motion of atoms and molecules. The faster the particles move, the greater the thermal energy. Friction is one of the most common ways mechanical energy is converted into thermal energy. That's why brakes become hot and why no real machine is 100% efficient. Electrical energy is associated with the movement of electric charges, usually electrons flowing through a conductor. It is one of the most useful forms of energy because it can be transmitted efficiently over long distances and easily converted into other forms. Electric motors convert electric energy into mechanical energy. Electric heaters convert it into thermal energy, and light bulbs convert it into both light and heat. Nearly every modern device we use today depends on electrical energy, making it one of the most important forms of energy in modern society. Nuclear energy is stored within the nucleus of an atom. It is released through nuclear reactions such as fission and fusion. Nuclear fission is used in power plants to generate electricity, while nuclear fusion powers the sun and stars. Even a very small amount of matter contains an enormous amount of energy, making nuclear energy one of the most concentrated forms of energy known. Radiant energy is another name for electromagnetic energy and refers to energy carried by electromagnetic radiation. The most familiar example is sunlight, but radiant energy also includes radio waves, microwaves, infrared radiation, ultraviolet light, X-rays, and gamma rays. Radiant energy travels through empty space and can be converted into electrical energy by solar panels, into thermal energy when absorbed by objects, and into chemical energy during photosynthesis. Sound energy is produced by vibrating objects and travels through air, water, or solid as mechanical waves. Human speech, music, and thunder are all familiar examples. Because sound requires a medium to travel, it cannot propagate through the vacuum of space. Sound energy is often produced whenever mechanical energy causes an object to vibrate. Chemical energy is stored within the bonds that hold atoms together in molecules. Gasoline, batteries, food, and wood all contain chemical energy. During a chemical reaction, these bonds are broken and new ones are formed, releasing or absorbing energy in the process. Chemical energy can be transformed into thermal, electrical, or mechanical energy and plays a vital role in both living organisms and modern technology. One of the most important ideas in physics is that energy is constantly changing from one form into another. Consider the battery-powered grinding tool we used in a previous lesson. Chemical energy stored in a battery becomes electrical energy. The electric motor converts that electrical energy into mechanical energy to spin the grinding wheel. Some of the energy is transformed into thermal energy and sound. Although the forms of energy change, the total amount of energy remains constant. In conclusion, one of the most important principles in all of science is the law of conservation of energy. Energy cannot be created and it cannot be destroyed. It can only be transferred or transformed from one form into another. Whether we are studying a falling object, a spring, a battery, electric motor, or even the sun, this same principle always applies. Understanding how energy changes form while the total amount of energy remains constant is one of the foundations of physics and engineering. Thank you for watching.